Russia, in Southeast Asia, 2 branches in Africa, and 1 branch in South America. So the most important, let's say, skills of Ortea is the experience due to the long history, the flexibility to produce a lot of customized products according to the needs of customers and the specification of projects, etc. We do start many times to manage the project from the beginning, to give our consultancy to the project and give the best solution for the installation. We have very good reaction time. So Ortea is not a very big company, but it's also very, let's say, quick in reaction and very reactive with the contact of customers. The research and development part is very important because we are investing each year a very good amount of our incomes to develop new technologies. That's why we are now able to produce electronic stabilizers till 4,000 kVA, which is a very high power. We take care about our customers. You know very well that without customers we cannot live, and customers without suppliers also cannot go ahead. So we take very well care about all our customers. So we are always present in the market and help our customers at the maximum and give not only sales, but mostly solutions and support. We do a lot of trainings each year. Unfortunately, this year, 2020, we have not had possibility to make our usual training because of the COVID situation, but usually we do perform like 4 to 6 trainings in different languages. We invite our customers and distributors and end users to come to our factory and also see and make a training on troubleshooting, repairing, and intervention on our units to improve their knowledge and to make them comfortable with our products. We are a company certified ISO. This is very important because it's many times requested also on the projects that the supplier must be certified. We are growing from the 2010 till last year very well because we are quite doubling our performances this year, even if we have had the COVID, but the numbers are very good. We are just minus 3% against last year. And the next year is, let's say, budgeted to be more or less at the same level of this year. We are present quite all over the world. As you can see, Italy is a very important country because we are close in and we are directly connected. Europe also is an important company. These are mostly for power factor correction systems. And Africa, Middle East, East Europe, Asia, and America are mostly absorbing isolation transformers and voltage stabilizers. Africa, especially, and Middle East are very in need of voltage stabilizer, including Asia, where we have very good activity, but I think we can have better performances in Asia. Some of our references in the world, so you can see that we are in a big connection with the very high-end users and very big names. And as you can see, there is 1 or 2 companies based in Bangladesh which have a lot of our products installed. So this is the company, and then we can start now to go with voltage stabilizers. So voltage stabilizers are basically needed when you have voltage fluctuation. So when you have unstable power supply, the voltage stabilizer will solve these problems to reduce your loss of security, loss of many failures, loss of data when you have a blockage in your installation, etc. So the voltage stabilizer will be an efficient and reliable solution to help you in this. So this can happen when you have a weak distribution line. So you have unfortunately, in many countries, in developing countries, the lines are not that well made, or you are in a position in the distribution line that you are unluckily at the end or at the beginning of the line. So you have either a very high voltage, or sometimes you suffer voltage drops. So this can be solved by using a voltage stabilizer. Also, being in an isolated operating system, so with an own generation, that can be also very important due to some instability in the consumption and the reaction of generators. When you have private homes or private premises, and you have a lot of consumption due to air conditioning, pumps, big kitchens, etc., that can create a lot of demand, while the line maybe is not allowing this kind of demand. Also, being very close to a big industrial plant will not help you to have a good voltage supply, because in starting in and off, on and off, the big power plants can absorb a lot of power, and in that case create some voltage drops during their starts, etc., that can be creating troubles to your lines. Or having also a sensitive industrial plant, when you have like LCD screen production for mobile phones, or for computers, or for television, or you have pharmaceutical processes or data center which are very sensitive because they are treating some sensitive area, radars in the airports, etc. So these are applications where you can have a lot of troubles. So the solution of having a voltage stabilizer is, as we said before, very cost-effective and very interesting because of the prices, because the price of a voltage stabilizer is anyhow very low in front of a UPS in general, even if they do not do the same job, but mostly people think that they can do the same job. The accuracy of the voltage stabilizer that we produce is 0.5%, which is a very high accuracy. The reliability and robustness of the unit, and in different types of environment, the possibility of carrying a lot of inrush current, the high efficiency, the simplicity of the use, no introduction of harmonic distortion, and a lot of other characteristics of the stabilizer make the solution very, very interesting and give you a steady feeding of your load. So the different applications can be in industrial sectors, in food and beverage, in tertiary sectors, especially for data centers, laboratories, etc., or even in industry, can be in pharmaceutical applications, or any manufacturing in general, telecommunications like radio, TV station, etc., hospitals, offices like public sectors, and renewable sources for wind and solar farms. So how to proceed with this selection of stabilizers? Very easy. So you need to know the number of phases you have, a single phase or three phase, the voltage that you are in, so the nominal voltage of your line, the variation of your voltage in income side, so how much it is plus minus, which is very important, because sometimes people do not think that having a very high variation, especially in minus, that introduce a very high current, have a big influence on the construction of the unit. The type of technology is linked to how is the sensitive your load. So if it is a load that needs a very quick reaction or not, a normal load will need an electromechanical unit, and a very high sensitive load will need a static unit which have a very, very quick reaction. We will see later on the presentation, for example, that the static is correcting in less than 3 milliseconds, which is a very high speed. Then you have to determine the power. So how is the power? Where you will install it. So if it is indoor, outdoor, which kind of ambient and environmental situation you will put the unit, and the accessories that you may need to install on the unit. So we have different types of accessories: bypass, isolation transformer, breakers, filters, etc. So the main, let's say, how it works, the main functioning of the unit is very easy. So you have a booster, which is a transformer in reality, that is working at the opposite of a transformer. So the primary is used as a secondary and vice versa, because our primary will be the secondary. So in way that when you have the input, the unit will see how is going the level of the voltage. Give the electronic board will analyze this and give the instruction to the regulator to put in the primary side of the booster at a configuration, but which is the secondary in installation in this case, to inject a vector that is positive or not negative to add or reduce the voltage. It seems very simple at the end, but needs a little bit to be deeply analyzed and checked, because everything is done in some milliseconds, but the configuration is not difficult at the end. So we do have different type of voltage stabilizers. They have always the booster transformer, which is one of the main part, the regulator, and the auxiliary circuits, which are the electronic board. So this is what we call the heart, the muscles, and the brain. So the brain will analyze how is going the heart and give to the muscles the information to add or reduce the income voltage to have always at the output side a steady voltage. So you can see here that we have different types of models that can be single or three-phase. Single phase, we can reach 135 kVA, and in three-phase, we can reach 6,000 kVA. You can see here that we have different solutions with different configurations, etc. Also, the range of variation can be symmetrical or asymmetrical. That can be also driven to all the units. So all the units can be having the same range. This is the electromechanical or what we call servomechanical voltage stabilizers. Then when we reach the static solutions, so no moving part, no servo regulation, we will have the unit based always on a buck booster and an electronic board that will analyze and give also the correction of the voltage, but fully electronic, no moving part, and only based on IGBT systems. So you will see here that we still have the heart, the conversion unit, which is now the muscles instead of the moving regulator, and still the electronic board, which is the brain. So the brain will always analyze the situation, see how is the heart, and give the order to the conversion unit, which is not the regulator in this case, but it is the electronic regulator, to add or reduce the necessary voltage for the steady output. So in this range, we do have single and three-phase. We can reach in single phase 40 kVA maximum. Here we have always a symmetrical variation. We don't have asymmetrical variation because the IGBTs do work only on a simple and one way and cannot be asymmetrical. The three-phase can reach, as you can see, 4,000 kVA. So this is the static units. The accessories we can add to our units are, as you can see, different types. So they can be interrupting devices, circuit breakers, bypass, etc., with our isolation transformers, SPDs, filters, different configuration with stainless steel cabinets or AC outdoor, so the stainless steel cabinets for outdoor application, or with AC cooling systems, different IP levels with the neutral point reactor. It depends on the situation of the customer. So we do have also some special voltage stabilizer, but they are in reality they become like a standard because the application is very easy. Like for telecommunication, we use them for BTS applications. They have always the same configuration. What we call also line conditioner, which are acting directly on the lines with a certain configuration that you can see the details here. Later on, after the presentation, we can share these presentations through email and download, so it's very easy. So you can have all the details. Or broadcasting also. So for the TV transmitters and radio transmitters. Or food and beverage application, which are IP54 already equipped with special air AC cooling system and with special isolation for water, etc., because they are used in food and beverage applications. So this is the voltage stabilizer. Now we can see the isolation transformers. So isolation transformers are mostly very, oh, sorry, here. Okay, they are dry type transformers. So we do produce them with resin impregnation. So they are no cast resin. Mostly use it for UPSs because we have a very good relationship with many UPS producers, and we deliver them a lot of isolation transformers for their UPS. There are also transformers for other applications like solar system, photovoltaic, rectifiers, general purposes, step up, step down, auto transformers. We do have also some other application like reactors for medium voltage, etc. So these are very easy systems. So most of the time, the reactors can be single or three phase, can be on air or with iron core, medium voltage or low voltage, peak reactor, blocking reactor, in rush current limiting systems, and the tune reactor for power factor correction systems. We are a certified company, so we have an insulation system certified UL on request, which is not always there because it depends on the final destination or the specification of the project. We do reach 5,000 kVA. We do have a very high possibility and skill to design special units according to specs. We do use aluminium or copper winding system according to the customer needs and the different vector groups. The construction is very easy. As you can see, we do have winding in aluminum or in copper. We do use magnetic core in grain-oriented or standard laminated sheets, insulation material according to the project. In pronation, we do use polyester resin, which is polymerized in oven later on. We do use dolphin polyester resin, which is a special one, but it is made under pressure, so it is under vacuum or under pressure and then polymerized in oven. The most important thing is that we do comply with the AN 60076, which is for isolation transformers, and we do make 100% tests on each unit. So as you can see in the photo here, we do have two controls during the production process. We do make the tests during the process of the production two times, one in the middle of the production and one at the end of the production, so to be sure 100% that the units are functioning at the best and 100%. In fact, on such fixed unit, we quite do never have fails because of the feedback from the market on failure on such unit is really very few. It's something like 0.008%, which is very small ratio. We do have different solutions also in different types of cabinet that can be with or without accessories according to the customer needs. So this is a quick presentation of the isolation transformers. Now we will see our suck compensator systems. The suck compensators are very important when you have problems on very sensitive loads, like for example producing LCD screens or pharmaceutical processes, where even if you have a small problem on the voltage side, you can have big troubles on the production lines, or even in pharmaceutical application, be obliged to stop totally the process and maybe throw away a volume of material that can cost a lot. So the sags are usually generated in the medium voltage side of the lines, but they are reaching the low voltage side, and these have like a 4% in impact on the industrial segment, and 0.15% on the service segment. This means that mostly the industrial people do suffer a lot of critical power due to sag in the world. Basically, the energy companies delivering energy suppliers have to give a report of how many sags a year they have and where and how they occur. This is very important because people can see when and how they have such problems. So this can be a very high cost. Why a very high cost? Because you can scrap a lot of raw material, waste time to restart the line for production, probably have a stop for a long time due to troubles you can have on production lines, like breakdown, etc., and damages and malfunction of machinery. So this can be having a very high cost that people do not know, and sometimes don't know how to solve the problem. So if you make a good survey of your line and see all the reports from the main supplier of energy, you can eventually find the cause and then try to find a good solution to reduce the impact of such troubles. So basically, when you have a good supply of energy, you have all the values of the voltage and the RMS correctly at the best. The problem is that this is not always the same, because many times you have harmonics, you have frequency variation, you have swells, you have sags, you have transient spikes, and you have sometimes a voltage interruption. So each problem of these do have a solution, like a frequency converter to solve the problem of the frequency. Sag and swells can be solved by sag compensator, supply interruption by UPS. So we may face during the execution of our industrial or service process different problems, but we can have also different solutions. So when you have a problem on the voltage, you can have many interruption, and the voltage quality can be affected. So it's important to have a very high quality of the voltage to continue the production or the service. Sorry. Okay. So it's important that you keep under control your voltage incomes and monitor everything to have all the informations, then be able to react in case of interruptions or sags or transient to reduce the possibility of failure in production or in service system. So the most important cause of voltage sags are mostly coming from the public network, but they are due to switchings from loads that are very large loads or very big motors on medium or high voltage feeding. So this can be creating a lot of sag and swells in the line, and some people who are not using such big motors or such big industry and are next to these industry will suffer from these sags and swells and have troubles with production lines or services they have to supply. So the sags are usually erased or let's say events that affect the medium and high voltage network, but they are also propagated directly downstream to the low voltage side. So mostly of these sag and swells can cause troubles on the low voltage side more than on the high and medium voltage side. So here you see some examples of how in Europe the classification of the sag and swells and their effect on the lines are. I don't know if in your country there is a control on or a monitoring of such phenomena, which are very important, but people do not see very well. So sometimes you need to make a very good network supplying and network analyzing to be sure about how and when these kind of problem can occur. Here an example of how is the supply in Italy. Most of the sags and swells are registered, and the public supply company of Energy is obliged to give a report each year to everybody, to all the industrial companies, especially to let them know all about the situation of the phenomenon of SAGs. So this is the effect of the SAG and swells on the lines in Italy that have a big problem. They can create big problems, especially for the industries. So how the oxygen SAG and compensator do provide such solutions? So the oxygen is an instrument which is a voltage stabilizer in reality, working on a normal variation, but can be able also within 3 milliseconds, so less than a wave of voltage, to compensate what is missing till minus 50%. So if you have a SAG till minus 50% on a line within a wave, the oxygen SAG compensator will be able to give you always a steady output. So you have, like in this figure, which is very simple figure, which is a very simple figure. So you can see that having a problem on a part of 2 or 3 waves, the output from the oxygen unit is perfectly steady and compensated. So till minus 50% for 1 minute, the unit is able to compensate these SAGs. So having an efficiency which is over 98%, you will have always your feeding of a line with very high quality of voltage level. So the unit is can be plus minus 10% or plus minus 15% as a standard, but can reach also minus 40 or minus 50% as a SAG. The efficiency is over 98%. It's always a modular system, as you can see. Can be with different additional components that we can add to the unit, like bypass system or interrupting devices, etc. Have a connectivity because it has a Modbus TCP/IP connection system, which is also available on other units. This is to allow people also to make a monitoring of the touchscreen unit and see what is happening on their SAG compensator. We installed 3 SAG compensator in Zurich airport in Switzerland, and this is protecting the radar systems because they are very, very sensitive. So as you can see here, the main line can have an income, but can have, like for some periods, some sine wave, a SAG. You see the input is in yellow, and the output will be as it's described in green. So will be always steady. This can be done for 1 minute compensation because the unit is using special ultra capacitors. The ultra capacitors will give the energy to correct these sags or swells in the line. So we do have different configurations. Plus minus 10%, plus minus 15%, and minus 40 or minus 50% on the line. So you can have communication, you can add accessories. It's more or less like any normal or, let's say, static voltage stabilizers. We do have different powers. We do reach 2000 kVA plus minus 15, minus 50%, and 3200 kVA plus minus 10, minus 40%. So these are the biggest unit. So what is the comparison that you can have between oxygen and online UPS? The oxygen is able to correct the line within 3 milliseconds. Online UPS do not do it. Voltage compensation is minus 50%. Online UPS will balance to on batteries and will have no interruptions. So the suck compensation within oxygen is 1 minute. Depends on the battery level of the UPS. You can reach different minutes here. The maintenance is very easy. The only big difference between oxygen and UPS is the price, because the oxygen is being at the end, and voltage stabilizer is less expensive than a UPS, including the battery application, and have less maintenance and smaller footprint. The different applications that you can have are electronic industries, some high-end user food and beverage and very automated lines, robots for applications for different high-end industries, medical applications, also pharmaceutical production lines and cooling systems, data centers and banks, telecommunication, etc., and renewable energy. So these are the most important applications for suck compensators. Now we can see quickly the harmonic filters. You know that when you have problems of harmonics on the line, you can use different solutions. The solutions are mostly power factor correction system with filters and isolation transformer to attenuate the harmonic levels. When you have higher harmonic level, the only thing to block these harmonics totally is the active filter. So when you have a lot of reactive power and you have flickering or load unbalancing for the loads you have for your loads in general, you need a solution. So the harmonic will create troubles on your lines. So basically, you can solve it by using an active filter. The active filter is the only solution to kill totally the harmonics. So the most important cause of the harmonics are especially the loads that are very, very varying. So they like welding machine, molding machines, electronic devices, UPSs, computers in general, loads that are like fluorescent lamps, etc., can create a lot of harmonics that will be distributed in the line. So this will create troubles between the main line and load. So can create overcurrents that can create some burning of some components, or also an overheat of the cables, vibrations, reduce the power factor, which make also impossibility to absorb the total power of a transformer that we have, of a power transformer that we have of, like, for example, 1000 kVA. When you have a power factor of 0.7 due to harmonics you have on the lines, you will be obliged to absorb or be able to absorb only 700 kVA instead of complete 1000 kVA. So these are some of the let's say troubles caused by the harmonics. So when it is needed a harmonic filter, an active filter is needed when you have high-end user level. So when you have a situation like hospitals, data center, heavy industries, very sensitive loads, pharmaceutical applications, companies who very sensitive like radio, TV, broadcasting, telecommunication, etc. So they need to have very high power quality solutions. So the working principle of the harmonic currents is very easy. I think you should know, all of you, how it is influencing the line. So it's creating a lot of troubles to the line that can be thrown back to the source. So having an active filter will kill these harmonics and give the load and vice versa against the main feeding line, so from the public distribution line, do not throw back harmonics to the line. So this will improve the energy quality. So here, let's avoid these parts. So when you have a need of you have troubles on the line and you have high harmonics, you have to measure your THDI and THDV, which are very important points to measure to make a good selection of your harmonic filter. Well, here there is a formula of how to make an evaluation of the real value of a harmonic an active filter, where to position an active filter is very important, because it's important to put it on the right position in the main line to avoid troubles. Otherwise, you will have the opposite solution. Here you can see that the position of a harmonic active filter is very important to have very high benefits to avoid the problems. So you can see how is the circulation of the harmonics inside the line. So when you have harmonic circulating due to some machines, etc., so you can put a harmonic filter in the right position to avoid that this can circulate all over the line, and avoid to extend the harmonics inside the line. So here you have how to apply and where to apply an harmonic filter. So this can be done here locally in our factory. So you can send us your measurements and data, and we can give you the and SLD, and we can give you the right solution to help you to make the better positioning of your better choice and better positioning of your active filter in the right position in your appliances. So the active filter is very easy to install at the end, because it's like a power factor correction system, very easy to install, and will help you to have a better energy quality. Well, these are a little bit the modular system will help in having possibility to improve the power of an active filter if you want. So you can start with the 60 amps and then increase the power step by step. We have different configuration, can be floor mounted or wall mounted situation. We do reach 300 amps that can be also put in parallel to improve the power, so to increase the power, and can be different IP levels with neutral or without neutral, depends on the installation, if it's only 3-phase or 3-phase plus neutral. These are some characteristics of the active filters. So this is the range, so till 300 ampere with 4 wires, so 3-phase plus neutral, or only 3 wires, wall-mounted units or floor-mounted units. So it depends on the type of installation. How to connect the unit to the load? It's like a PFC, so it is in parallel and on the line, not in series, and it's not like a stabilizer or a sub-compensator. And how to connect the line exactly in the right position. It's important to have the best solution from the unit. Okay, how the wiring of the paralleling of the units inside a line, how to make it correctly, what to avoid. If in case you have power factor correction system present in the line and you have to add an active filter, the PFC must be detuned to avoid the harmonics to burn the capacitors. I think my time is quite finishing, and these are some advices